What is consensus algorithm and why does Bitcoin need it? Welcome to Prime Number. Today, I'd like to talk about the consensus algorithm that Bitcoin uses. But before we talk about it, let's step back a little bit to talk about a general database design. Because Bitcoin is just a public database that anybody can write into. For a traditional database design, we have to come up with a master or slave architecture. There's only one single node that can be used to save the transaction, and the other node can be used for reading. The master node can be used for reading as well, for sure, but you cannot write in parallel from two nodes. Assuming we write a transaction into the master node, the slave is always trust the master node, even though once the slave is down, the database is still functioning. Because when a slave comes up, it will always pull and always trust what the final state the master node has. But using this design, you have to have a master node that is always available to write into the database. But what if the master node is down? So the later design come up with a fault tolerance that if the master node is down, there would be a election happened to elect the next master node or the leader node. The protocols such as raft will elect the next leader node, and once the node becomes the leader, the write transaction will go through the leader as well. That will increase the availability of your database. But that brings another problem. Since any node can be elected as a leader, there's no source of truth that the state from a single node is trustful. We can think of a scenario that we have 5 nodes, 3 of them is down. We left 2 remaining still alive. Should we still allow the transaction to be written to the 2 node? You may say, why not? The database can still be functioning. But what if the 3 node and the 2 node, there is a firewall in between, and the nodes on both sides think they are still fully functioning? So the 3 node will become a small cluster, and the 2 node will become another cluster. And all of a sudden, when the firewall disappears, which side of the node make the call? When things like this happen, this is the time we need a consensus. Consensus is a fault-tolerant system that agreed on a single final value among a distributed, unreliable participants. Since Bitcoin is still a database, so it should still follow the CAP theorem. Consistency means every read should return the most recent write or an error. Availability means every request should get a response, even though the response is not return the latest data. Partition tolerance means the system should be still functioning despite a number of messages has been dropped or a number of nodes has been off the network. The CAP theorem means in a distributed environment, it is impossible to simultaneously support more than 2 out of the 3 guarantees. Let's keep in mind what 2 of the guarantees Bitcoin support that the other one Bitcoin doesn't, while we discuss the consensus algorithm. Even though Bitcoin is a database, but it's different from a traditional database or a centralized database, is that every transaction has to be signed by the sender, which means you don't need to guarantee that the transaction is valid. You just need to validate the transaction through the signature. For example, if you do threat analysis, if you are an attacker, are you able to forge a transaction that paid coin to yourself? No, because all the transaction is signed by whoever hold the private key. So what can you do? Well, if you are a malicious node, you can, for example, just ignore some transactions. Similar to denial of service attack, you can ignore some non-public key hash. You never pick up the transaction to form into a block. But it doesn't hurt because any miner, any node in the network can pick it up and put into the block. Since the transaction is valid and is signed by the sender, and you cannot do DOS attack because any miner can pick up the transaction and produce a block, there's nothing you can do for consensus, right? So what is the most important thing in Bitcoin? Right, this is a doublespender attack. This is the only reason that the consensus algorithm exists in Bitcoin. The consensus is hard. Not only there's no identity for any of the nodes in Bitcoin network, there's no total number of the nodes. There is no majority of the node. And even worse, you cannot trust or you cannot even use a global time to decide which transaction comes first. Given that a lot of limitations, how do you design a consensus that can prevent the double spend? I think this is a major contribute that Bitcoin provides to the whole cryptocurrency world. It opened the doors to build a real decentralized application. Any node can join and drop. Doesn't depend on any global time, but still as a whole, the system is trustful. Since there is no master node in Bitcoin network, there's no leader, there's no golden state all the other nodes can follow, then the Bitcoin consensus algorithm is fairly simple. Always extend the blockchain to the longest one, which means when the soft fork happens, you always produce your block, append it to the longest chain. It may sound much simpler than the other consensus algorithm used in the database industry, such as raft. But it's not. Given that the Bitcoin node spread in the different geography locations, each of the node has different network latencies. They may have their own global timestamp. To find just the longest blockchain is not as easy as you might imagine. So Bitcoin introduced the proof of work, which slowed down the whole process and let the things settle down, and then to make it easy to achieve the consensus. The proof of work, in order to produce a block, the miner need to guess a nonce and put the nonce in the same block to calculate the hash value. The hash value has to meet some criteria such as how many leading zeros in the hash value. The total time to produce a block is roughly 10 minutes. 10 minutes is long enough for the majority of the Bitcoin nodes to get the transactions and the blocks. Using this trick to make everything settle down, it makes much easier for the whole network to achieve a consensus. It may sound brutal and you may think it's not working, but in reality, it works pretty well. Let's take a look. Let's simulate how an attacker would do a double spend. This is current state of a blockchain. This is block number 1, number 2, number 3. An attacker named Alice. She wants to purchase something online from Bob, but at the same time, she wants to spend the same money to herself. So what would she do? She would create a transaction, Alice to Bob, and send to the Bitcoin network. At the same time, she would also create another transaction, Alice to Alice, another Alice address, belongs to herself as well. Assuming both transactions would landed on the same Bitcoin node, the node only trusts the first transaction it received.
So no matter which one comes first, there's no double spend. There's only either Alice pay to Bob or Alice to pay to herself. So another situation is one transaction sent to one node and the other transaction sent to another node. And both nodes is so lucky they come up with the block successfully, which means they guess the nonce successfully, which meet the hash value criteria. So both of them would append the block into the blockchain. So one node would append Alice to Bob in her blockchain, and the other node would append Alice to pay Alice to herself to his blockchain. So at this time, none of the blockchain node know the existence of the other transaction, which the input, as we discussed, has to be referencing to a previous output. So both are referencing to the previous output. That's why if the both transactions send to the same node, the later one will get dropped. But since it's sent to different node and they are referencing to the same transaction, it's still valid. So both blocks are valid. Does Alice successfully do a double spend? Well, at this time, we don't know. So the consensus rules is the next block should always be appended to the longest chain. So which one is longest chain? We don't know. Then, who decided which chain is the valid chain? It's the next block. So whoever come up with the next block is either add to this chain. So if that's the case, Alice to pay to herself would be a valid transaction, and Alice pay to Bob will be ignored by all the following blockchains. But what if the transaction is appended to this one? Then Alice paid to Bob will be a valid transaction, and Alice paid to herself will be an invalid one. But if you say that it still could possible that two different nodes come up with the block and append to each one almost at the same time. Well, in reality is the possibility to produce the new block appended to a different chain is exponentially dropped given there's another block append to the blockchain. At this time, this chain will win. So you might feel like, even though I describe Alice to pay to Bob is the valid transaction and Alice pay to herself is malicious, but they're identical. From Bitcoin network point of view, both transactions are valid and both of them are treated equally. The only thing that the network wants to prevent is the double spend. It doesn't make judgment which transaction is a good transaction. So if the left side of the chain is being picked as the blockchain, so the Alice pay to herself is a valid one. The Alice pay to Bob is a malicious one. You may ask, Alice already paid to Bob, and that payment was recorded in the blockchain, and Bob may already send the product to Alice. That's true. That's why the common sense in Bitcoin is that even though your transaction is recorded in the blockchain, but there's no more blocks appended, this transaction is not confirmed. The common sense is after 6 confirmation of your transaction is treated as a successful transaction. So 6 blocks, each block's produce time is about 10 minutes, so that's about 1 hour. The Bitcoin database is not a consistent database, which means after a successful write or successful commit into the database, there's no guarantee your transaction can be read from the other node. It may not even exist on the other node. But Bitcoin database is eventual consistency. So how long it achieved eventual consistency? The common sense is 1 hour. So after 1 hour, your transaction is guaranteed to reach the majority of the Bitcoin network.
Bitcoin has been criticized by use too much energy for this proof of work consensus algorithm. The followers built new consensus algorithms such as proof of stake or delegated proof of stake. We can talk about them in following episode. Thanks for watching. Comments below what you want to see in my channel. See you next time.